chapter 5, IP routing basics. Okay, so in this chapter we will discuss about the basic principles of router, how the router selects optimal routes, understand the contents of routing table, and more advanced features. Okay, routing features. So here, first thing, basic concept of routing. Why we need routing? See here, we have two different networks. One is N, one is M. Network means we have different computers. Each computer will have a unique IP address. Okay, and each unique IP address belong to different subnets. So how we can communicate between a computer in one subnet or one network to another computer in another subnet or another network? That's what we're discussing. So computer in network N or subnet N want to communicate with the computer in or subnet in another network M. Okay, these things are communicated with the help of network devices, layer 3 devices. Mostly we use routers. Okay, the router is the one which performs data communication between the device in one network to another device, another network. Okay, that's what mentioned here. To implement communication between different subnets or different networks, the network devices needs to forward the packets. Okay, network device means router. They want to forward the packet from one network to another network. Okay, now this is that concept. Okay, the device, a host in the network N, want to send a data or packet to another host in network M. So what we have is we have gateway or routers in between. Okay, this is my gateway router. I will forward to my gateway router. From there, this router will check which is the best path. It will check the routing table and it will forward the packet to the best route. From there, it will be forward to another router. Finally, it will reach the gateway of the destination network, and they will forward to the which one, destination host or destination network address. This is called as how the route performs the packet forward. Okay, we will forward the packet to the destination route, destination, sorry, the gateway of your network. That will be a router. That router will check its routing table, and here they will find what is the best route to reach the destination. They will forward to the next router. They will also find the best route or optimal route. Then they will forward to another router, and when finally reaches the gateway where the next network is connected. So for these things, no, every router will have a routing information. They have a routing table. They will check these information in the routing table. Okay, so see here, this R router. Okay, we have two other routers, say R1, R2, R3. This R1 has to reach 10.1.1.0/24. This is my destination network. So in the routing table we have, see, three fields here in this example. Okay, first is destination network slash mask. Okay, then outbound interface through which exit interface you are reaching that network, GE00. What is my next hop? Next hop means what is the IP address of your next router. So we have two routers here, but I will choose this one. Maybe this is the best path, so I will choose this path. Means next hop will be 1112, IP address of next hop router. Okay, then a big IP routing table. Okay, see here, same, this R2 router has different entries in its table. Okay, to reach 11008, this one /8, I want to go through this G00, right? This is exit interface, or outbound means exit interface through which I can go out. Okay, then what is the next hop IP? So from this router, what is the next router? R1. So what is the IP here? 222/30. Just give 222, no need of mentioning. I need to mention the subnet mask. Now for to reach 13000/8 from R2, the routing table entry C 13000/8. What is the exit interface? GE01. I will go to this one through GE01. Okay. What is the next hop IP? From here, the next hop is 3332. Like this, you want to put this. Okay, every router will have some routing table, and we want to find out the best route. We will not choose all the routes. Okay, we will not add all routes. Okay, the best route with the minimum cost or best path will be chosen. Okay, then generation of routing entry. There are different types of obtaining methods of obtaining route information. Okay, first is direct route. Direct route means automatically generated by device and point to local direct network. Okay, so here R1 is connected to 10110. See, on the right side it is connected to 10110/24 through GE00 because I assigned an IP here. And same R1, I call it as R1. Okay, this R1 is connected on left side with another network 2110/24 and the interface is GE001. So this is automatically added into the routing table. No need for you to manually add, okay? Because it is connected through direct point-to-point links or cables, okay? So the protocol, okay, direct routing protocol. See, protocol name is direct. The destination is see first one 10110/24. Yes, this one. What is the outbound interface? How we reach this network from R1 GE00 to reach 21110/24 from R1. The direct is 21110/24. Exit interface, outbound interface is GE001. Okay. Now this is direct route. No need to do anything. Whenever you connect the interface and assign an IP address, that itself becomes direct route. Static route means manually you want to configure. It is not directly connected to your router. We want to manually configure. See, I am going to configure a route on this router. Say I call it as R1 this, R2 this, R3. Okay. From R1, I want to configure a route to network 30.1.1.0/24. So from this router, I want to manually add a route because I am not directly from this router. I am not directly connected to this one. This is part of this router. Okay, R3. So static routing is a protocol, static. Then destination is 3110/24 mask also there. Now outbound interface. How you will exit this router? GE001. Okay, this is the exit interface. This one through this way. GE001. I'll go. Okay, this outbound. The manually we are adding. Dynamic route means you are not going to add anything. The routers will exchange their routing information to another router. Okay, we are not manually adding. We are not configured anything like direct route. Okay, what we do, whatever information the router will have now, they will exchange their routing information to another router. Example, this router has a OSPF route. Okay, to 40110, and from this router I want to reach that. Okay, so what type of routing is OSPF protocol? So what they will do, they will forward the route. Okay, I have a network called as 40110 which I obtained through. Okay, I have some routes. Okay, what I will do, I will configure OSPF between these two. Okay, so what happened now, this router will exchange this information to this router. So routers will automatically learn the information by using dynamic routing protocol. You don't want to manually add, you don't want to configure IP like this. Okay, whatever routes if you configure OSPF between these routers, whatever router routes or routes the router has in its table, it will be automatically exchanged to other routers. So here I will get, using this protocol I will get 4110/24 this no route, and the exit interface is or outbound is GE002. Okay, this is what direct static dynamic mentioned here. Different dynamic routing protocols are there like OSPF, IS, RIP, EIGRP. We will discuss later. See direct routes. Again, what is direct route? From R to RTB, I have two different routes or two different routes. Okay, one is connected via 10.0.0 to G00. So when I configure IP address in G00, this will become another network. So the first network direct is direct protocol 10.0.0/24. The next two of IP. This is the next two of IP. Okay, whatever IP address we have, then the next two. Okay, then G00 is the output interface. Okay, next network is 2110 direct. The next two of IP. What is the IP address assigned for next router? Okay, then 2112 and the IP sorry, next two of is G00. Okay, then now if the interface which you are connected is down, that route will not be added into his routing table. See, RTB has two network, one on the right side 10.0.0.1/24, via G00, and on the right side it has 21.110/24. Okay, this is IP. These are IP. Network will be like 2110. Okay, two different network on left and right. Okay, but problem in left side G00, this cable is down. That means this 10.0.0.0 will not be added in the network because routing table, because it is not active. So only active networks will be added. See here, G001 is active. And one side I give 2112, another side I give 2113, and this is IP address network means 24. No, 24 means first three octet is network. So this will not change. 20.1.1. Last part will be say 0. This network is the only network or route added in the table, because even though we have two networks on left and right, one side the interface is down, so that route will not be added. Only this route is added, 2110. Okay, mentioned here. Then how do we select the optimal routes, yani the best possible routes? Okay, so every router have a routing table. So in Cisco we use the command show IP route. Here we use the command display IP space routing table. Okay, so the router, Huawei router has, in this case, router has 1, 2, 3, 4, 5, 6 networks. Okay, destination or networks and mask also given. Protocol they use static and direct. Then preference 60, 60, 0, 0. Static means 60, preference means 0. Okay, cost of that route, flag. Okay, next hop, then interface name. Next hop means the next IP address of next router, nearest router. Then this is interface we are connected. Okay, so here the main thing is whichever route has highest, which one, preference or lowest preference value. See here 60 and 0. Which one is lowest one? 0. So we will prefer, this will be your highly preferred route. Okay, so whenever we have different routes to network, same network we have different routes. Okay, so but we want to check the route preference value, whichever is lowest one. Okay, that will be the one which we'll choose. In the Cisco we'll call it as administrative distance. Okay, so whichever route has minimum administrative difference, they will be given higher priority. So here we'll choose this routes with 0 preference. They are going to same destination and the preference is lowest one, we'll choose the lowest one. Okay, we'll see examples. Okay, so whatever preference I told, everything is here. Okay, then see here cost. So whichever, this is for route. Okay, now for every interface we have a cost. So whichever interface cost is lesser, we'll choose that one, or metric. We'll see that example. Okay, then this is destination network, this is protocol static or direct. This is the preference I told you, preference of the routing protocol we are using, which route. Then what about the link cost? Then next IP address, then interface. What about flag D? Okay, flag is not that much important. Okay, just leave it. Okay, remaining all here. Okay, then how do we compare the route preference? Okay, we have many routes. Okay, same destination, same subnet mask, means choose the highly preferred route. Highly preferred route means whichever route has lowest preference value. This number is less means choose that will be the highest preferred. Okay, so choose the one with lowest preference value and add it into routing table. Okay, see here, from this RTA I want to reach 10.0.0.0/30. This is our 10.0.0/30 connected to another router. Okay, so I have two routes. One is OSPF by this way, another one is static. Okay, so static and OSPF. So if I go for static, I'll choose this route. So this route means the next hop IP is 3112. Okay, if I choose OSPF, this is the route. Okay, so the next hop is this way, 2112 to reach here. Okay, now both static routing protocol and OSPF has this preference 60 and 10. Okay, which one is lesser? Okay, the preference value. So this preference value less means this is the one we will choose. Okay, understand what I'm telling? So we have two routes to same destination, but protocol is different. So check the preference value, whichever has lowest preference value, that should be given high priority. We'll choose this one. Okay, that is this route table. Okay. Then again, two routes protocols are same. So to reach 10.0.0.0/30, I have two routes through this way and this way. Both are configured in OSPF protocol. So which one I will choose depends upon the cost of the link. If I go through this from RTA to this one means the cost is 10 plus 10 20. Okay, say okay. If I go through this way, the cost is 10. So which one is lesser? This one 10. That's why I choose the second one, because RTA to reach 10.0.0.0.30, the next hop is 30.112. So this way. Why I choose? Because the cost of link is 10. But if I go through this way, 10 plus 10 20. How to go here, then only reach here. So 20. We'll choose only 10. Okay. A route preference. Now this will be asked. So direct route means the route preference is 0. Static means 60. Dynamic routing protocol OSPF, we have 10 and 150 internal route and external. So remember this table, they may ask you what is the preference of these routes. Direct route means 0, 60 means static, OSPF internal means 10, external means 150. Okay, remember these numbers. Now metrics basic concepts. Okay, so routes with destination mask are same means check the preference. Which routing protocol has lowest preference, take that one. But metric, the preference also same as we discussed now. Both are routing protocols are OSPF, they have same. Which one preference value means I will check the cost of the link. So lowest one I will choose, either lowest one or higher preference I will add in the routing table. Okay, route based forwarding. Next one is the longest matching. See, whenever a router receives a packet, no, it will check the destination IP address of the packet with all the routes in the routing table, bit by bit. Which route has maximum bits matching? We'll choose that. Okay. See here in the example, I have my destination IP. I want to send the packet to 172.16.2.1. I have different entries in my table. I have one is 172.1.0 this slash 24. Another route is 172.16.2.0/24. Another routing entry is 172.16.0.0.255.25 and 16. Which route entry I want to choose to send packet to this destination? First, that's the first thing. Okay. So first thing is write down the destination address and routing table entry in binary. So I'll write 172.16 this part binary all. Okay. Now see, my destination is 2.1. This is 172.16.1.0. Okay. So 172 same, 16 same. Now 1, I write 1 here. Okay. And see here, up to here it was matching. Okay, 255. Now that means network part, right? So up to here it was matching 1, 2, 3, 4, 5, 6, 7. Remaining, okay, 1, 2, 3, 6. Remaining two are not matching, so I cannot use that mismatch. Next entry 172.16.2.0, 255 3 times 0. That means first three network part. Okay, so 172.16 common. Now two binary same like this. So these two are exactly matching. Network part. Okay. Now routing entry 3, 172.16.0.0. That means only first 16 bits are network. The remaining full host, sorry, remaining full host. Okay, so it will be 00. So these 00 not matching with this two. So only matching is this destination. I want to choose this entry because the network bits are matching exactly the bit by bit matching between this one and routing entry. Remaining one is not matching. Okay, maximum bit match we have to choose. Then another one. Destination IP is 192.162.2 slash, okay, 24 you can take. Okay, so I have three destination, three routes in my table. 0.192.168.0.0/16, 192.168.2.0/24, 192.168.3.0/24. Okay, that means first slash 24 means network bits will be first three. So here I have 192. It is common in all. Okay, 168 common to all. Now remaining 2, third octet, this is 0, not matching. This is 2, matching. This is 3, no matching. So this is the only network I can choose to send packet to this destination RTA. Clear what I'm telling? Okay. Now again longest matching, same thing. 192.168.3.2. This is a network I want to reach. See, first one only 16 bits matching, 192 and 160, remaining two mismatch. Second one 192.168.2, so only 192.168 matching, 3 is not matching. Third one 192.168.3.0, 3.2, so first 24 bits matching. Choose that particular network or route to send the IP address or a packet to this destination. Route based forwarding process, same thing which I told you, just check that. My destination IP is 40.0.1.2, so whichever is matching, choose that. Okay. IP routing table, I told you, every router has a routing table. So there will have network address, mask, its next hop IP, then type of protocol, is it static, dynamic, or like that, then exit interface. So we have to choose the network with matches, maximum bits matching in destination IP address, and choose that one. Okay, mentioned here. Then static routing, I told you, manually add a network which is not connected to you. So here for RTA, I want to add, see, I have two networks. Okay, one is static, manually added, which is a remote network. Remote means not directly connected. So from RTA, 2110 is the remote network. So how I learned that one? Manually adding, I manually add. So static, what is the next hop IP? From this router to reach here, next hop will be 10.0.0.2. Next hop IP. This IP, next hop IP and network is different, okay? So here you may ask, brother may ask, Mr. Why you put 10.20.1.10? It is not here. See, I have IP address here. See, 20.1.12/24 and 20.1.13/24 on these networks, okay? 24 means first 24 bits network. That means it will not change. So first three part will be network part, 20.1.1. Last part is host. Host means all zeros. That's a good, okay? And direct from this router 10.0.0.0, that is direct network. How we can access this, okay? So this is direct and this is static. Static means you want to manually add the routes which are not directly connected. This is not added by you. It will automatically add whenever you configure IP address for this interface. It will add it. Okay. How do we configure the static address? So IP route. One method is by using next hop IP. IP route static. The IP address, its mask, length, and next hop IP. Another one is through outbound. I'll show you the example. IP route static, IP address, mask, length, interface type, interface number. You can specify both. I mentioned next hop and interface inside. I'll show you the example. From RTA, I want to reach 2110. Okay, what I will do, I'll write IP route static CRTA 2110 and the subnet mask is 24, 255 3 times 10. Next hop is, see, from RTA to reach this network, the next hop IP is 10.0.0.2. If I choose, this is next hop IP. Okay, what is the first one? Next hop IP. Second one is interface type or exit interface, yani. To reach this network 2110, my exit interface, how I am exiting, GE00. For RTA, this is an exit interface, not this one. Here in the case, both are GE00, but actually, we should always think exit interface means where I am exiting. Next hop means not my IP, another router's IP. Okay, remember that one. Default route means if I want to send a packet to a destination, that destination address is not in my routing table. So what I will do? Okay, I want to reach these networks, but these routes are not in my table, in my RTA table. So what I will do? I'll make a default route, which will be like network will be all zero, mask will be zero, and it will be reaching up to the next router. From there, they will take care of. That's called as default route. Used only when packets to be forwarded do not match any routing entry in table. So I want to send a packet to a destination. That destination network is not matching with any entry in the routing table. So I will just mention, I don't know, just put type route is static. Where I want to go, 000. What is the match? 0. Then what you should give, write the next hop IP. I will take you till this next router from RT reach here. From there, they will find out, they will send to everyone. Okay, that's what. Why we need this is, say sometimes this is my internet router, this is my LAN network. Okay, I want to send a packet towards X, some other network which I don't know the destination, not in my table, means I will forward this up to the router, an internet router. They will take care of. That's what IP route static. Any network, I don't know network, any mask, I don't know. That's why up to where this router, internet router, they will manage them. Okay, they will forward packets. Then dynamic routing. Static means you want to manually add a network route in your table, but problem is whenever the routes, any router interface gone down or any changes happen, static routes, they cannot adapt to the link changes. Okay, they cannot do manually. We want to go and they cannot understand that automatically. We want to go and manually remove the route and add another one. Okay, then dynamic routing means not like that. The routes are discovered automatically. Every router having some information, they will forward that information to other router, so they will learn themselves. If any router gone down, if any interface gone down, that router will inform the one others will be getting information that this interface is down, don't go there. That link, that route will be removed. Stat means not like that. Once you set a route, no, it is permanent. If anything happens in the link, you are not aware of that. You keep on still sending the routes or packets in that route. You have to manually go and change delete the route so that inform others. But here not like that. They will automatically update. Every router will automatically update the routing information to other routers. So whenever a link go down, they will inform you. Example, from this, here I am reaching this, okay, via this network. Okay, static. I put the manual route like this. This. If this link is down, the static routing, no, you have to go and manually change. But if it is an OSPF, means if this link is down, you will get message from other routers that this is down. So you can choose another router, another route. This is all dynamic routing, OSPF. Okay. Different types of dynamic routing protocol. IGP based means RIP, OSPF, ISS. Exterior gateway means BGP. Classifying by working mechanism and routing algorithm, RIP distance vector based on the distance and direction. Link state means state of the link. Okay, remember these things. Maybe in the multiple choice question they'll ask you what are the names of interior gateway routing protocol, RIP, OSPF, ISS. Names of exterior gateway protocol, BGP, not BJP, BGP. Names of distance vector routing protocol, RIP. Link state, OSPF, ISS. Remember this. Okay. Then advanced routing feature. Routing recursion. So here, routing recursion means a route that points to a next hop which is not directly connected to router. Example, in RTA, I have a static route towards 3120/24. I want from RTA, I want to reach this network. And I give the next hop IP as 20113. Usually, next hop IP will be the IP address of your next router, right? Whichever router is connected to you, what is IP, that should be there. So in that case, it should be 10.0.0.2, but I write 2113. Where is this 2113? It actually belongs to this router interface G001, 2113. So this router cannot reach here using this because there is no connection between this to this. So what I need? I need a extra route. So what I will tell them that I will add a new route like IP route static reach 2112. Okay, sorry, the network 211024, and the next hop is 10.0.0.2. Okay, so this is not enough. Okay, I want to reach, see, by this line what the machine understands, RTA should reach 3120. Next hop is 2113. This is the next network. I cannot reach it. So what I will know, to assist this one, I add a new router, that is route recursion. IP route static. To reach this 2110/24, use the next of 10,002. Okay, this is what route recursion. Without this route, I cannot reach this because this is connected to 21, and from 21 it's connected to this one. Okay, equal cost route. I have two routes from RTA to this one 10,000/30. One is via 2111/30. Another one via 30,111/30. One is G00, one is G00. But both costs are 1010. Which one I'll choose? I'll choose both. And what I will know, I will share the load. If I have more packets, some will go to this path, some will go to this path. This is sharing. Equal cost route means we have two routes to same destination with same cost 1010. I can choose, I can add both in my routing table and I will share my load. More packets means I'll share, some will be go to this way, some will go to this way. Okay, then floating route means backup route. See, to reach 20,030, RTA has two routes, one via RTC, one via RTB. Okay, and here what I will do, both are say equal cost. What I will do, I will make one route as floating any backup route. Backup means if the main route is down, then only the backup route will be active, otherwise it will be deactivated. See here, I have one route IP route static. Okay, 20,00030. How? Through 10,112. This is the main route. Second will be IP route static, same network, through 10,122. This is 112, this is 122. Preference 70. That means here this one has no preference, means this is the lowest one. We will choose this is the main route, the first one. Whenever this main route is down, then only they will make this as active. So this is floating route or backup route, because the preference value is more 70. Default is say 1 or 0 something. Okay, but here this is more compared to this one, this is more. So what happened, you will not choose this route, this will be floating or backup route. Whenever this route is down, then only we'll choose this one. Okay, that is backup route. See here, I mean, my packets will go through this word. So actually, this is 60 preference. Okay, so we have two example. One is preference 60, one is 70. Okay, so actually, it will go through this path whenever, and this will become backup path. Whenever this route is down, link is down means I will choose this path, which is with 70. Okay, because 60 is down means we can go for next one 70. No other routes. Okay, that's what we call floating static route or backup route. CIDR means classless interdomain routing. That means every network will have different subnet masks, not fixed to like 24, 16, 8. No, that boundaries will be broken. Okay, so here it is 22 means network is 22 bit. This is network 23. This is network 21. This is 23. Again, what I want to do, I want to summarize all these networks into one network with a same subnet mask. Okay, this is what called as route summarization. Okay, see here 192, 168. What I will write all those which one binary value and find out how many are common. So up to here common now 111. From here it is different. So up to here 128, 64, 32, 16, 8. This is 8. Okay, so 8 every network of this one 192, 168, 12. So this is 12. 8 plus 4 12. This is 10. 8 plus 2 10. This is 9. All these networks of different subnets now I am going to combine, summarize into one particular network so that routing will be easy. You don't want to route to different networks, one route with summarized one is enough. Okay, so what I will do, 192, 168, I write all the networks in binary, then I will check how many are common numbers. Okay, so how many bits are common. So up to here it's common, so this is 8. Then how many network bits? 16, 17, 18, 19, 20, 21. That's why the summary for all these network is 192, 168, 8.0/21. Okay, how Mr. you got 21? 16, 8 plus 8, 16, 17, 18, 19, 20, 21. Mr. Why you got, how we got 8? I don't want to use all these networks. I will make it one network. How we got 8? The last bit, common bit is 111. They belong to 8. That's right. Okay. Then how do we summarize again? Just to see 192, 168, 1, 2, 3, 4, 5. If you start no summarizations, what happen? No, the router has to add all the networks one by one. So the routing table will be disturbed. More memory will be consumed. What I will do, summarize all into one single network. Okay. So see here, and how I'm doing this. Okay. Here also, instead of sending adding different routes like 10.1.10, 10.1.20, I will make a summarize. I will add a summarized route here. How will add summarization? I'll show you. It will reduce the size of the RAM size or memory size for the routing table. Okay. See, I want to summarize 192.168, 1.0/24, 2.0/24, 3.0/24. How I'll summarize this into this single network? Write the binary of all networks. Okay. Now see how many bits are common. 192 all have 192 common. 168 all have 168 common. Now 1, 2, 3. Here 1 means bind to this one. 2 means bind to this one. 3 means bind to this one. So up to where we have common? Up to here we have common. Okay, what is the value here? 192, 168, 0.0. That's why. But how, Mr. You got 22? 16 network bits, then 17, 18, 19, 20, 21, 22. That's why it is summarized. So instead of sending, adding routes for each network in the router and making the routing table RAM memory bigger one, I summarize these routes. Some people will, some protocols we have automatic summarization, some have manual. Okay. We will do manually, we have to add network, or we have auto summary on means automatically they will summarize and put into one. Okay. This one, IP route static. Okay, we can summarize. Problems are there, just go through. Okay. I'm not going to the problem, just go to the black hole and all. Okay. We need to see. Summarization is done again. How to summarize? Again, see 10, 110, 10, 120, 10, 130. I put 10, 1, 1.0, 2.0, 3.0. So what about the common bits? First two common, then remaining up to here 0. So how many networks are, how many network bits? 16, 17, 18, 19, 20, 21. Okay. 17, 18, 19, 20, 21, 22. So 10.1.0/22 is the summarized network. Okay, see 22. How does a router select optimal route? First compare the preference, no, whichever has lowest preference value. So compared to 60 and 70, 60 is the lowest one, choose that one. If that will be added in the optimal route, lowest preference value. Okay. Then same preference means compare the metrics, that cost of the link, the one with the lowest link will be added. Okay. Then what do I, how do I configure floating route? Floating route means two routes to same destination, but one should be made a backup or floating route by giving preference value more than the original route. So configure a static route with same destination, network segment and mask as primary route, but different next hop and larger preference value. Okay, we can have a different next hop. The next hop will be different. Exit interface will be different, but also preference will be larger. And what is this summary route for 10, 110 and 24 and 10, 11, 130 and 10, 190? Okay, that you want to write down in binary. The first two are always matching. So 10.1 is matching. Remaining code, the binary for 1, 3, and 9. Take that binary. How many are coming common? And do that thing. Okay, this will be your homework. Answer is this one. I know that, but still you do yourself. Okay, this is what coming under chapter, I think 5. Bigger chapter, but it's very important chapter. Okay, stop recording.